Hey everybody, welcome back to our flipped classroom for chemistry. Today we're talking about average atomic mass. So we've already talked about isotopes and what those are, and that they are atoms of the same element that vary in the number of neutrons in the nucleus and therefore in their mass. And we've talked about mass number, which is the sum of the protons and the neutrons in the nucleus and is always going to be a whole number. But if we look at the periodic table, we can see that what we have on the periodic table are not whole numbers. And we want to make sure that we understand what it is that we're seeing on the periodic table. So on the periodic table, we have what we call atomic mass or average atomic mass. And that is the average of all the naturally occurring isotopes in nature. And it takes into account how common those isotopes are. And so we average it based on what we call abundance, which is expressing as a percentage how many of each of the atoms of that element in nature that are each isotope. And so we're going to use that to calculate that average atomic mass. It's a pretty simple math process, so let's walk through the steps and then we'll do a couple of practice problems. So the first thing that we're going to do when we're calculating average atomic mass is that we're going to, and what we're going to be given is the masses and their percent abundances. So the first thing we're going to do is convert percent abundance to a decimal. And we're going to do that simply by moving the decimal 2 places to the left, because we know that percent is out of 100. So by moving the decimal 2 places to the left, we're making it a decimal instead of percent. The next thing we're going to do is we're going to multiply the mass of each isotope by the abundance of that isotope. Again, we're going to be given mass and abundance. So that abundance that we just converted to a decimal, we're going to multiply that by the mass. And we're going to repeat that for each isotope. And then we're going to add up those products. We're going to sum those products. And that's it. We're done. Easy peasy, okay? Don't have to divide by anything. We've already done that by dividing by 100 when we moved the percent 2 places to the left. So no dividing by anything at the end. We've already done that. So let's take a look at a problem. We actually have a couple here. So our first one, we're going to tackle boron. And you can see that what we're given is the actual mass of boron 10 and the mass of boron 11 and the percent abundance of boron 10 and the percent abundance of boron 11. So what we're going to do is we're going to change this percent abundance to a decimal by moving the decimal point 2 places to the left. So our percent abundance becomes 0.199. And this percent abundance becomes 0.801. Now we're going to multiply this mass by this abundance. So we have 10.0129 times 0.199. And we're going to add that to this mass times its abundance. So we have 11.0093, times 0.801. And so when we do that math problem, we get here 1.993, although this should only have 3 sig figs, so we know it's only significant to the hundredths place. And here we have 8.818, and again, because this only has 3 sig figs, this is only significant to the hundredths place. So when we add these two numbers up, we know we're going to need to round at the hundredths place, and that's going to give us 10.81 atomic mass units. So, pretty simple math. The hardest part of it probably is just paying attention to the significant figures and keeping track of where those go. So let's do one more practice problem. So we're going to move down here and we're going to take a look at neon. So once again, I'm going to move that decimal place 2 to the left. So that's going to give me an abundance of 0.9048 for neon 20. And now be careful, when it's already a decimal, you still have to move that 2 places to the left. So this is going to become, we're going to move that 2 places to the left, 0.0027. And this one at 9.25 is going to become 0.0925. And now we're simply going to multiply the masses by the abundances and add them up. So we have 19.9924 times 0.9048 plus 20.9938 times 0.0027 plus, I'm going to slide this over a little bit so that you guys can see it, 21.9914 times 0.0925, and that's going to give us 18.089. But keep in mind, this only has 4 sig figs, so it's only significant to the hundredths place. This one is 0.0567, 2 sig figs, so it's significant to the thousandths place. And this last one gives me 2.0342, 3 significant figures, so it's only going to be significant to the hundredths place. So when I add these all up, I need to make sure that I round it to the hundredths place, and that's going to give me 20.18 AMU. As always, I hope this has been helpful. If you have any questions, please make sure you ask me tomorrow in class. Look forward to seeing you soon.